All right, I'm going to talk today about section 1-3, entertainment expenses. All right, and in the warm-up, you've got 5 entertainment expenses listed at $7, $16.50, $12, $6.50, and $10. All right, and the first warm-up question is asking us to find the difference between the minimum and maximum expense. All right, so the first thing you'd want to do is to identify which of those is the minimum expense and which of those is the maximum expense. All right, so looking at those, it would appear as though $6.50, sorry, let me go back, that $6.50 is the minimum expense and that $16.50 is the maximum expense. All right, so in mathematics, whenever you see this term difference, that always means to subtract. All right, so it wouldn't make sense to do the minimum $6.50 minus the maximum $16.50. A small number minus a bigger number always gives you a negative. So what we want to do here is to take the maximum, which is $16.50, and we'd want to subtract the minimum, which is $6.50. And by the time we've done that, we get $10. All right, so $10 would be your answer there. That is the difference between the minimum and maximum. All right, the next one says to find the mean expense. All right, so when you're finding the mean, remember the symbol we use in mathematics to do mean is x bar. So that when you find a mean, x bar, what you do is you find the sum, which we oftentimes use sigma to denote that, and we divide by n, which is the number of values. All right, so when we do this, for our mean, we would want to add all those together. So we want to add the 7 and the 16.50 and the 12 and the 6.50 and the 10 together, and by the time we've done that, we get a sum of 52. So that sigma is 52, and the n, remember, is the number of values. How many did you sum together? So how many values did we add together, or how many values do you have total, which in this case is 5. All right, so we want to take the 52 and we want to divide by 5, and by the time we've done that, we get 10.4. All right, so the mean expense would be $10.40. Remember, these are dollar figures, so we'd want to put them in dollars and cents. All right, the third problem here, the third warm-up problem, asks us to find the median expense. All right, so in median, we got to be a little bit careful. So what I'm going to do is I'm going to go through and reorder these. All right, so I'm going to reorder our values, and I'm going to put them more in an order that should make sense here. All right, when you're finding the median, always be careful. You must reorder your data values from the minimum to the maximum. All right, you have to do that every single time. In fact, most of the time when people mess up the median, that's what they did wrong, is they did not order them from the minimum to the maximum value. All right, so definitely go through and do that to start. Now, you don't need to do this to find the mode, right? The mode is just the one that shows up the most. Doesn't need to be ordered from minimum to maximum in ascending order. All right, you don't need to do this to find the mean, the average. The average, just adding them all together and dividing by how many you have. It doesn't matter which order that's in. It doesn't have to be in ascending order, minimum to maximum. The median does require this. So be careful anytime you're asked to find the median of some data values. Make sure to order them from minimum, smallest number, to maximum, largest number. All right, so let's go through and do this. Look at your 5 values. Which one's the minimum? We already figured that out in number 1, right? This right here, 650, is the minimum. All right, so that is our first value. Now, since I already used it, I'm going to cross it off our original list. And that lets me know that I already used that. All right, 2 reasons. First, I don't want to count that same value twice. Secondly, I don't want to, miss it. So once I put it into the new ordered list, I want to cross it off the old unordered list. All right, now the next one, next highest value appears to be $7. So that would be our next value. That's that one. Again, I'm going to cross it out once I've used it in the new list. Next one is $10. So cross that one out. The next one is $12. Cross that one out. And the last one is $16.50. Cross that one out. Alright, so now you've got 5 data values. Now they are ordered in ascending order from smallest to largest, also known as minimum to maximum. Alright, now the median is the one that's in the middle. Alright, so sometimes you have 1 in the middle, sometimes you have 2 in the middle. And the way to know this is if you have an odd number of data values, there is 1 in the middle. There's one single middle value, and that's called your median. If you have an even number of data values, you have 2 in the middle. Alright, so if you have an odd number, you have 1 in the middle, that's called your median. If you have an even number of data values, you have 2 in the middle, so you have to get the average of those. You have to find the mean of the 2 in the middle. Alright, so counting our values, we have 650, 7, 10, 12, and 1650. That's 5 data values. There is 1 in the middle. Alright, it's easy to tell that that's in the middle because there's 2 values on the left, 650 and 7, 2 values on the right, 12 and 1650. So your median here is $10. And once again, this is a dollar figure, so that's why I'm putting it in dollars and cents. Right, so there's your warm-up. Alright, so moving along with a little bit of vocabulary. This section really deals with measures of dispersion. Alright, so let's first start with, maybe talking about the difference between these measures of dispersion, and the previous ones that we talked about back in section 1-1, which were your measures of central tendency. So there's an important distinction between these two. All right, the measures of dispersion kind of are lumped together, like we're doing here in section 1-3. The measures of central tendency were lumped together in section 1-1. All right, and the measures of central tendency, the ones that we talked about previously in 1-1, those were mean, median, and mode. All right, now the mean, the median, and the mode, those were ways of measuring the center of the data. The median, like we just did on the last warm-up problem, was the actual physical geographic center, middle of the data. All right, the average is kind of the middle number, like, if you were to randomly pick a number somewhere, it would likely to be very close to that average right in the middle, right? So that's kind of a numerical average of the numbers, or numerical center. All right, the mode is the data value that shows up the most. So that's kind of a central number because it shows up more often than the others. All right, so mean, median, and mode are all ways of measuring where is the center, where is the middle of the data. All right, so that's what we previously learned about in section 1-1. Where was the middle, where was the center of the data? The mean, median, and mode were called measures of central tendency for that reason. Right? They were ways of measuring what's the tendency of the data. Where's the tendency of the center of the data going to be? So mean, median, mode find where the data tends to be in the middle, the central tendency. Okay? What we're learning about today are measures of dispersion. So think about that word dispersion. That means like to have dispersed or spread out, right? Dispersion means spread out. So measures of dispersion are ways of measuring how spread out is the data. So that's a pretty important difference than what we already learned about. Measures of central tendency, the mean, median, and mode, measure where is the center of the data. That's why they're called measures of central tendency. These that we're about to learn about are called measures of dispersion, because instead of measuring where is the center of the data, These measure how is the data spread out from each other. How are they dispersed? All right, so let's talk about the first one. The first one I actually had you do on the warm-up, but I didn't call it the range. I just told you, hey, I asked you to find what's the difference between the minimum and maximum. All right. Well, mathematically, we call that the range. So the range is the difference between the maximum and minimum values. And just quick heads up here, you always take the big number minus the small number. Right? The larger data value minus the smaller data value, the maximum minus the minimum. Otherwise, you get a negative number. All right. So your range should be a positive number. That's why you do maximum minus minimum. All right, and you've probably done these before. You were first introduced to range back in elementary school, so that shouldn't be a new topic to you. May not have seen it in a while, but you probably have seen that at some point. That's the range. All right, the next few there, the next 4 are probably ones that you haven't seen before. Maybe you've seen or heard of standard deviation, but probably the other ones are unfamiliar to you. So let's talk about those. All right. After range, the next one, the second on our list, is mean deviation. All right. So think about what those 2 words mean. All right. What's the meaning of those 2 words? The first is mean. All right. We know what that means, right? It's an average. Right? The second is deviation. So to deviate from something means to kind of stray away from it. All right. So the mean deviation is kind of a measurement of how far, on average, does your data deviate or stray from the mean. All right. So you know where the kind of numeric center of your data is. It's the mean. The mean deviation measures, all right, now that we have all this data, how far away are our data points, our data values, away from the mean on average? Are they all really closely packed or clustered toward the center of the data? Or are they all really spread out and dispersed, or they deviate a lot from the mean, from the average? All right, so that's a measurement of mean deviation. That's what that tells us. How far is the data spread out? How far does the data deviate from the mean? All right, now let's look at the next one on the list, number 3, the mean absolute deviation. So this is pretty much the same as the one above, except we've added the word absolute. All right, and you've seen the word absolute being used in a math class before with absolute value. So think back to a previous math class, maybe your last math class you took. You probably dealt with absolute value at some point pretty recently, right? What does absolute value do? Right? And remember, our absolute values are always positive because they are a distance from 0. All right, so absolute value is positive always because it's a distance from 0. Distances are always positive. All right? Absolute value is a positive distance from 0. All right? Mean absolute deviation, that word absolute, it's the same meaning. It's a positive distance, except now it's not a positive distance from 0, from absolute value is. Mean absolute deviation is a positive distance from the mean. How far is it away from the mean? So it doesn't really matter if it's above the mean or below the mean. It's still just a distance away from the mean. So there's really no such thing as positive or negative here because it's a distance, right? That's kind of the difference between numbers 2 and 3 here, the difference between mean deviation and mean absolute deviation. The mean deviation, you're subtracting, the data value minus the mean. And sometimes that can be positive, sometimes that can be negative for the second one, mean deviation. So this one right here can be positive or negative. But this one right here, mean absolute deviation, can only be positive because, once again, it is an absolute value. It's a distance, right? So it doesn't matter if you're above or below the mean. Right? It'll always be positive. All right, the variance. The variance is the average squared difference between the data values and the mean. All right, so that's kind of like taking the mean deviation, which is the average distance between the data value and the mean, and then squaring it. All right, so you're taking this average distance and you are squaring it. Right there, it's just to square it. So remember, squaring means to raise to the second power, the second exponent. So this one right here, number 4, it's the same as this. You're just raising it to the second power, to the second exponent. All right, that's it. All right. Now, one of the things raising to the second power does, remember, is whether it's positive or negative. Anything to the second power, anything multiplied times itself will always be positive. So the variance will always be positive because a positive number squared is positive and a negative number squared is positive. So any number times itself is always positive. All right, so that's what variance is. All right, all you do is find mean deviation first and then square all those numbers. It's pretty easy. All right, now, because you square the numbers to find the variance, you unsquare it to find the standard deviation. So now, whatever you get for variance, you just square root it to get your standard deviation. All right, so that kind of, by squaring it, you get the variance. So by squaring it, you now have to unsquare it, and that's taking the square root. All right. Remember, squaring and square rooting are inverse operations. They kind of cancel each other out. All right, so that's a lot of information thrown at you. That's a lot of things that look and sound very, very similar. All right, and that can be tricky. So I'm going to show you how to do these using a table. And the table helps to kind of keep things organized and make it so it's easier to find. I'm also going to show you how to do it on a calculator, which is really the easiest way of all. Let the calculator do the hard work for you, the heavy lifting. That's really my suggestion to you. All right, but before we get there, I do want to show you the formulas for how to get mean deviation, mean absolute deviation, variance, and standard deviation. All right, so 4 formulas there. Now those 4 formulas are pretty ugly. They're pretty nasty looking, and they're really not fun to do because you have to find sums. So you gotta kind of do these separate calculations and then add all of them together. That's what the sigma tells us, and then divide by n. So in other words, find the average of that of those sums. Right. So it's really a very labor-intensive process to do these things by hand, which is why I would not suggest doing it. I would really strongly suggest you be able to use some sort of graphing calculator that will find this stuff for you. There's also all kinds of resources, websites, apps, that kind of thing, that will find you some of these statistical measures. All you do is just type in the numbers and it'll automatically spit out the mean deviation, mean absolute deviation, variance, standard deviation, those kind of things. All right, so let's look at this first formula right here for mean deviation. First of all, this first word says mean. All right, well, that means average, right? So look at what we have here. We have a sum, and we're dividing by n. That's the average. That's the mean. All right, so that's where that comes from. This word right here, deviation, means how far is it deviating away from the mean? And that's what's happening here. It's telling you in this section right here, what you're doing is taking your x values, there it is, xi, right there, and then you're subtracting x bar, that's the mean right there. So you're taking your data value and subtracting the mean. Now, if the data value is larger, greater than the mean, this number will be positive. Right? A big number minus a small number is positive. If the data value, your xi, is less than the mean, now you're taking a small number and subtracting a big number. Well, that gives you a negative number. So sometimes these things are positive and sometimes these things are negative. All right? But that's how you find mean deviation. That's the formula for it anyway. So if you were stuck to having to do this by hand, you could do it. It's just a lot of work. All right, now let's look at this one here, the mean absolute deviation. Notice the only thing different between these two terms is the word absolute. And notice the only thing difference in their formulas is now instead of parentheses like you have on the top one, now you have these guys, right? You have absolute value brackets. All right, so I'm going to go ahead and erase those so they're not getting in your way when you're writing your notes there. Look at these two formulas, right? They look identical with the exception of parentheses have now been replaced with absolute value brackets. Okay, so where before you could get positives or negatives, now you can only get positives. All right, so mean absolute deviation should always be positive. All right, now let's take a look at this formula and see how it relates to the one below, the variance formula. All right, the only difference is if you look back at the last slide, right, the definition of variance is it's the square of the mean deviation. So you're taking the mean deviation, which is right here, and you're now squaring it. It's the same thing, except it's been squared. Right? Now, it would be, by the way, just a quick heads up, the same as squaring this, right? Because the mean deviation might be positive or negative. The absolute deviation is always positive, but it doesn't matter whether it's positive or negative. Once you square it, you can take 5 squared, you get 25. If you take negative 5 squared, you still get 25. So it doesn't matter if it's positive or negative. All right, so really, both of these, you could square it. You could take the mean deviation or the mean absolute deviation. Doesn't matter which one. Just square those values, and now you get your variance. All right. All right, now I'm going to go ahead and erase those marks again here because I want to show you how the variance and the standard deviation are related. All right, so let's look at the variance formula. Let's look at the standard deviation formula. Look at this one. Now look at this one. Look at what's the difference. The only difference is that the standard deviation, this bottom one, now you take the square root. All right, so to go from the variance down to the standard deviation, you take the square root. But to go the opposite way, to go from the standard deviation up to the variance, and this is probably more likely to happen, to go from standard deviation to variance, now you just remove the square root. You just get rid of it, and you'll have the variance formula. So if you know what the standard deviation is, then you just get rid of the square root, and you'll now know what the variance is. We'll talk about that later. All right, so here's an example. It says, use the following dollar amounts Joe spends on dates. All right, so these are his entertainment expenses, right? He's going out on a date. First question is to find the range. So remember, the range is the maximum value minus the minimum value. All right, so we got to find, of these date expenses, where is the maximum value? All right, well, clearly this is the maximum value right there. All right, so that must be the girl he really, really likes, right? He's taking her out on a $184 date, right? Must be trying to impress her. All right, now we're going to subtract the minimum. All right, the minimum value looks like it's right below, right? It's 24. All right, so that is the minimum data value. Okay, and that must not be one he's trying too hard with, right? All right, only spending 24 bucks. He took her to Taco Bell or something. All right, so there's your maximum minus your minimum. All right, now when you subtract those, that's 160. All right, so that is the range of his entertainment expenses. Now, we're assuming that these are dollars, but and it actually does say in the instructions, use the following dollar amounts. So since we know these are dollars, we could put the dollar symbol in as our answer. I would suggest using units of measure whenever possible. All right, now the other ones, mean deviation, mean absolute deviation, variance, standard deviation. Look at the formulas on the previous page. Those are some nasty formulas, all right? So how do we do those? How do we do those to find those 4 values? Mean deviation, mean absolute deviation, variance, and standard deviation. Really, there's only 2 ways that I would recommend doing this. All right. The first and by far easiest way to do this is to use a calculator. All right. So I'm going to show you in just a minute how to do this using a graphing calculator. All right, now if you don't have access to a graphing calculator, it doesn't mean you can't do it. It just means it's a little bit more work, a little bit trickier. All right, not necessarily harder. In fact, it's basically you're memorizing fewer steps. You just have to do those steps by hand. All right, so let's go to it. I would recommend, if you're doing these, to use a table. All right. So notice all four of these: mean deviation, mean absolute deviation, variance, and standard deviation. All four formulas use x bar. All right, and you should remember this hopefully from a previous section here. X bar is the mean, it's the average. So the only way to get these four things, mean deviation, mean absolute deviation, variance, and standard deviation, is to know the mean first. So you have to first get the mean, the average. All right. So let's go ahead and do that here. Let's get the mean, the x bar. And if these are your 5 data values, okay, the way you get the mean, the average, is you take the sum and you divide by n. So take the sigma, divide by n. All right, and that actually is right there. Look at it. It says find the sum from 1 to n, so that's all of them, and then divide by n. All right? So I need to take these 5 values, 63, 31, 78, 184, and 24, and I need to find the sum and then divide by n. That'll give me my mean. So I'm going to add the 63 plus the 31 plus the 78 plus the 184 plus the 24. Alright, and when I do, I get 380. Alright, so I get 380 divided by n. N is 5. There are 5 data values. Alright, and when I do that, I get my mean, which is 76 even. All right, right on the dot, 76. So we don't have to deal with decimals. All right, so one of the issues, and we kind of we dodged a bullet on this problem. When you have means that are whole numbers, these problems are way less work. Right? When you have means that are, or data values, when your means and data values are all, whole numbers, it's definitely easier. If your mean or your data values are decimals, then it's definitely more work and probably requires a calculator to do. Right? Maybe not require, but for all intents and purposes, it's a lot of work. You'd want a calculator. All right. So let's go through and do these. The mean deviation is how far do these deviate from the mean. So what we do is we take the data value, 63, and we subtract the mean, 76. And when we do that, we get negative 13. All right? So how far do these data values, like the next one is 31, how far does it deviate from the mean? So you subtract the mean away from it. And when you do that, you get negative 45. All right, do it on all these. Take the data values, subtract the mean, and here you get 2. All right. Take the data value, 184, and subtract the mean, 76, and you get 108. And the last one, take the data value, 24, subtract the mean, 76, and you get the next one, negative 52. Okay. Now notice those mean deviations. Some of them are negative and some of them are positive. All right? So some of them are negative, some of them are positive. All right, that's going to happen when you do the mean deviation. In fact, almost always you'll have some negative, some positive. So don't worry about that if that's the case. All right. In fact, I'm going to show you right now how to know if you've done this correctly or not. For mean deviation, what you want to do, down below, look at what you see below. Look at this formula right there, down below. All right, it wants you to find the sum of the x minus x bars. All right, so in other words, you got to add all of these together. All right, so your numerator, we're going to add these mean deviations. All right, so let's add these deviations. We're going to add negative 13 plus negative 45 plus 2 plus 108 plus negative 52. If you put these together right now and add those into a calculator, you're going to get 0. And you divide by your n, 5, and you get 0. All right, now the mean deviation should always be 0. All right, and if you think about what a mean is, what an average is, we talked earlier about it. It's kind of the numerical center. All right, so if the mean is kind of in the center of all your data, it should make sense that, there's some numbers that are above the mean and some numbers that are below the mean. And if it really is the center, there should be an equal amount above the mean, and there should be an equal amount below the mean. And that's what happens here. Look, if I take the positives, 2 and 108, I add those together, that's 110, positive 110. Now if I take the negatives, negative 13, negative 45, and negative 52, if I add those together, I get negative 110. So I have positive 110, so that's the amount above the mean. And I have negative 110, that's the amount below the mean. So there's just as much above as there is below, which is why the mean is in the middle. It's the center. Remember, the mean is is kind of the real most important measure of central tendency. All right, now let's get the next one, the mean absolute value. All right, the only difference here between the mean deviation and the mean absolute deviation is you just take the absolute value. All right, so this should be easy for us. We just take the absolute value of negative 13. So the absolute value of negative 13 is positive 13. The absolute value of negative 45 is positive 45. Now please be careful. Once you've done a couple of these, people seem to think that absolute value means change the sign, and that's not true. Absolute value does not always mean to change the sign. What it does mean is that the absolute value is a distance and therefore must always be positive. So our first two were negative, negative 13 and negative 45. So to do the absolute value of those had to turn out positive. All right. Now the next one already is positive. So it does not change signs. It's already what it needs to be. It's already positive too. So remember, absolute does not mean always change the sign. It means always make sure the result is positive because it's a distance. Right? Here it's a distance from the mean. When it comes to absolute value, it's a distance from 0. All right, so let's look at the next one. We have the absolute value of 108. All right, so the absolute value of 108 is 108. Oops. And the last one, absolute value of negative 52. All right, now that one's a negative. If it's a distance, it can't be negative. So we just make it positive. All right. So now we have some absolute deviations. We have those deviations, and we took the absolute value of them. All right. So what we want to do down below is we want to find right here, this formula says to find the sum of all these things. All right, so we've got to find the sum. So add the 13, the 45, the 2, the 108, and the 52. Add those guys together and you get 220. And divide by your n. Your n is 5. That's how many data values you have. All right, now when you do that, you now get 44. All right, so what this is kind of telling you is that the average distance of your data values away from the mean is 44. All right, so if I took the distance between 63 and the mean, 31 in the mean, 78 in the mean, 184 in the mean, 24 in the mean, if I took how far those numbers are away from this number right here, our mean, on average, those numbers will be an amount 44 away from the mean. All right. So our data values are on average 44 values, 44 numbers away from the mean. All right? So that kind of gives you some important information about how spread out your data is. In other words, how dispersed your data is. We now know that on average our data is dispersed 44 units from the mean. All right, and so that can or cannot mean a lot, kind of depending on relative to the mean, right? So if you're 44 away from the number 10, right, you're way away from it, right? But if you're 44 away from a million, you're still pretty relatively close, right? So that's kind of what, well, we need to start talking about here. Is how, all right, so now we know the mean absolute deviation, how far we are number-wise away from the average, but let's talk about getting that into a relative number so that it's relative to the mean itself. All right, and that's where variance and standard deviation come into play. They kind of relate these mean absolute deviations, these mean deviations, to the mean itself. So, you know, a distance of 10 doesn't always mean the same thing based on what your mean is. All right, so let's look at variance. Look at the difference between the mean deviation formula and the variance formula. All it is just square it, right? So you take your mean deviation, which for the first one was negative 13, and you square it. You multiply it times itself. Well, that's 169, right? Negative times negative is positive. So it turns positive anyway. The next one, negative 45, and you square it, right? So now that's 2025. Take the next one, 2, and square it. All right, and that's easy, that's 4. All right, take the next one, 108, and square it. Well, that's not as easy. It's 11,664. And the last one, take negative 52 and square it. This is a negative times a negative, and you get positive 2,704. All right. So a real easy way to mess this up is to put this into a calculator. Like probably a lot of you didn't do negative 52 squared in your head, right? Probably most of you wouldn't have even done that on paper. Most of you probably would have put that in a calculator. Be really careful. So just let me put this here. Negative 52 squared is positive 2,704. So if you actually put that in your calculator using the parentheses, you'll get the right answer. Right? But if you do this in your calculator, negative 52 squared, your calculator follows order of operations. So it's going to want to do this exponent before it multiplies 52 times the negative. All right? So here you'll get 52 squared, which is 2,704. But then it's going to multiply by the negative. It's going to do PEMDAS. It'll do the exponent before the multiplying. So now it'll take your answer and make it negative. All right? So this and this are not the same thing. All right? So if you're putting this in your calculator, make sure to use those parentheses. Just about all calculators have a capability of you put parentheses in. All right. Now let's look at this formula down here. All right? That is all these squared deviations, but now you add them and divide by n, right? Well, adding and dividing by the number of values you have, it's a mean, right? So you're finding the average of all these squared differences, right? So you need to add these things together, right? So you're going to do this part. The numerator is the sum. You're going to add them together, the 169 plus the 2025 plus the 4 plus the 11,664, plus the 2,704, right? So you're going to add those things together, right? And that gives you 16,566 divided by your n value, which is 5. All right? And when you do that, you get, I'm going to put this down here, a little extra room, you get 3,000, whoops, let me erase that so we can see it better. get 3,313.2. All right. So there was your mean deviation. There was your mean absolute deviation. And here is your variance. Right? The variance tends to be a pretty big number. Right? Now for standard deviation, let's look at the formula you just used to get variance and then this formula. The only difference is there's a square root around it. So to get the standard deviation, it just equals the square root of the variance. Right? Well, let's say I know the variance, right? I just, like I do in the last problem, I just take the square root of it. One thing you should know is, yes, that is true, but that's how you get standard deviation. Let's look at that, what I just wrote down here, right here. Let's say I wanted to get the variance. Right now I'm showing how to get the square root of the variance. To get the variance, I would just square both sides, raise both sides to the second power. Right? So if I wanted the variance, right, I would just raise this side of the second power, raise this side of the second power, and those cancel out. So I know my variance is the standard deviation squared. Right? So here's how you find standard deviation. Here's how you find variance. Right? So if you know one, you should be able to easily find the other. All right. Well, we know one of these. We know the variance. We just figured it out right here. So to get the standard deviation of that, just take the square root of this. So I'm going to take the square root of 3,313.2. And when I take that square root, I get 57.56. Now there is some rounding involved, right? But it's approximately 57.56. Okay. So this is similar to our mean absolute deviation, except it's kind of accounting for the size of the numbers, right? So it's not just always how far it is away from it, right? It's how far it is away from it, the mean comparative to the mean, right? So like a big number, if you're way off, well, it's a big number. You should be, relatively off, right? Like 10% of 50 is a lot less than 10% of 5 million, right? So that's kind of what standard deviation accounts for. All right, so notice none of that was easy. None of that was probably very fun to do, right? That's a lot of work. And by the way, I just only had 5 data values. They were all whole numbers, and my mean, my average was a whole number. Imagine these all being decimals, right? That would have been even more work. Or imagine there being more than just 5 data values. What if there was 50? What if there were 500, right? Then that would really be a pain. All right, so a lot of times doing this is so painful to do by hand that it is really, in practice, rarely done by hand because it's really tedious and time-consuming work. All right, so let's talk about a better way to do this. I don't like to do things in a tedious, time-consuming way. I don't like to do things that way. I don't like to waste my time spending more time than what's necessary, but also think about all those places that we could have done something wrong here, right? There's so many spots where we could have messed up a calculation here or there, or misentered something into a calculator, right? We've all done that before. So we really kind of want to limit how many things can go wrong. All right, so instead of doing all this work by hand, let's let the calculator do the work for us. The calculator has a built-in way of doing this stuff for you. And really, if I want to go back to the last screen for a minute, really, quite frankly, the real reason why you would want to do all the things we just did in that last table would be to find the variance of the standard deviation, right? The mean absolute deviation, the mean deviation, these first two, those are really just used to help you find the variance in standard deviation. They're not really all that important as statistical measures in the first place. I mean, other than they're used to find the variance in standard deviation. The variance and standard deviation are used far more often and are far more important. So let's go through and do that on the graphing calculator. All right, so it kind of says right there in red, since variance and standard deviation are statistics, you go to the stat function on the calculator. So this is a TI-84. This is Texas Instruments 84. Casios have a very similar setup. So you would go into a very similar place on the calculator. But essentially what's happening is, since we're calculating statistics here, you hit the stat button to tell the calculator, hey, I want to do some statistics. All right. Now the calculator is going to tell you, hey, all right, you want to do some statistics, huh? Well, what data do you want me to run the statistics on? So you have to enter the data into the calculator. All right. So when you hit stat, the first thing that's going to come up is that top line, and it should already be highlighted and say edit. All right. And because chances are this isn't the first time using your calculator, you've probably already got some data stored in from the last time you used the calculator. So you want to edit your list and make sure that your calculator is going to calculate the statistics based on your new list of data rather than maybe a problem you did a week ago, right? So you hit edit, and you want to edit your list of data here. So when you hit edit, you're going to get something that you see kind of like in this top picture up here, right? You get lists of data. All right, now if it was already empty, maybe you cleared it out, or maybe this is the first time you're using that calculator, just enter the data right into L1. That's list 1. See, these are list 2, list 3, list 4, list 5. Those are empty because I'm putting all the data into one list, because they're all X's. They're all one variable, so I want to put them all into one list. All right, so I put them all into list 1. There they are. All right. Once I've done that, I have my list edited the way that I want it to. My calculator now knows what data I'm going to run my statistics on. So now I go back. I go back to stat, okay, because I've entered the data, but I haven't gotten any statistics from that data yet. So I go back to stat, but instead of hitting edit, my list is already edited. Now I hit calc. All right, and that's telling the calculator, hey, you want to start calculating statistics based on the data that I've already entered, that I've already edited. All right. Now notice when I entered my data here, it was all in one list. They were all X values. The problem gave these to me. They were X values. They were my XI values. All right. So since I have only one variable that I'm using, I want to click on the very first option here, which is one variable stats. Right? Now if I had, I'm going to erase this and show you something real quick. If I had data here, let's say, this was like 10, 5, 32, so on and so forth, right? Maybe I had some numbers there. Right? Now I have data in here and here. That would mean I have two variables. So now I would go down to there, to that second, and hit two variable stats. All right. So that's kind of how you know where to go. You just look at, well, how many variables do I have? Well, I got one, so I go to one variable stats. All right. If I have two variables, then I would go to two variable stats. It's really that simple. All right. So let's get rid of the stuff we don't need here. All right. So you go into one variable stats, and as soon as you hit that, this pops up, all right, in one variable stats. Now notice it says list L1. And this is really asking you a question. It's saying, is your list that you want me to calculate my single variable statistics on coming from list 1? Because maybe you didn't put your data in list 1. Maybe you had, the 63 and the 31 and the 78 and the 184 and the 24. Maybe you had it in list 5 instead. If that were the case, you would just change that number right there to list 5, and you would tell your calculator, hey, actually the data I want you to run statistics on is in list 5, not list 4, or list 1. Okay? Now in this case, the data is in list 1, so I'm not going to do that. I'm going to leave it as L1. This should be probably the default that comes up as L1. All right? Now the frequency list we'll talk about a little bit later, but basically, well, let's talk about that a little bit later. Let's not get worked up into that right now, but that can get a little bit tricky. We'll talk about it later. But you would scroll down to calculate. So hit this right here, go down to calculate, and now the calculator calculates statistics based on your data. All right? Now look at this right here. X bar is 76. Look familiar? The mean is 76. We already found that. Okay. Now let's look at some of these other ones. All right. Right below it says sigma x. Remember, sigma means sum. So what this is telling you is the sum of your x values is 380. Right? So if you actually took this data, this 63, 31, 78, 184, 24, if you took those x values and summed them, you added them together, you would get, what was it, 380 or whatever it was on that next page, right? Yeah, 380. All right. Now, if I took my x's and squared them and then added them together, get the one below, and really we don't need that one right here. So this one, really quite honestly, these three, we don't really need for what we're doing in this section. All right. Notice the n is 5, right? That's something that's important. Look how it's giving you your minimum. It's telling you your minimum Q1, Q3. It'll give you the quartiles. Those of you who are maybe used to using box and whisker plots, you've probably heard of quartiles before. If you've been in a stats class, you've definitely heard of quartiles before. It gives you your minimum and your maximum values, so you can easily find the range there. But this guy right here, this is what we were really after. Alright, so look at this thing right there. That's a thing of beauty. That number should look familiar. See, 57.56. I'm going to go back a couple slides here before we use the calculator. Look what we got for our standard deviation, 57.56. Look what the calculator's telling us, 57.56. The calculator's telling us the standard deviation, but we didn't have to do all that work right there. Doing all that work can take you, you could probably only do a couple problems an hour doing it this way on the table. But once you get the hang of how to do this on a calculator, you can do probably a couple problems a minute, right? It's way faster. So, part of, growing as a student, part of growing as a mathematician is knowing what tools to use in what situations. And if I were finding standard deviation, I would probably go to a graphing calculator real quick and let that do the work for me. Let that do the heavy lifting, right? This is a good tool to use here. All right, that's how you find standard deviation.